Right, this is section 8.2, which is systems of variables. This is systems of equations with 3 variables. And this is a little more complicated, but it's not hard. You just have to sort of pay attention to where things are. And what we're going to do, we have 3 different systems here. And notice we have x, y, and z. Those are our 3 variables. So I'm going to label this 1. This is equation 2, and this is equation 3. And we sort of have to narrow it down. So the first thing I'm going to do is try to get one letter by itself in terms of one other letter. And the easiest way to do that is this one, because there's only 2 letters here. So I'm going to solve this for z, and if I add 2y to both sides, I have negative z equals 2y minus 3. And if I divide everything by negative 1, I get z equals negative 2y plus 3. I'm going to call that equation 4. And what that does is that gets z by itself. So now what I can do is I can take this and I can plug it in for z in the other 2 equations, which will get it down so that I only have one variable in those 2 equations. So if I have equation 1 and I substitute that in for z, I have 2x plus y minus 2 times what z is. My z is negative 2y negative 2y plus 3, and then that equals negative 7. So I'm going to simplify this. I have 2x plus y, negative 2 times negative 2 is a positive 4y, minus 6 equals negative 7. As I combine like terms, this gives me a 5y here, so I have 2x plus 5y. But I'm going to move the variable to the other side. If I add 6 to both sides, that's going to equal negative 1. So that's one equation. If I look at equation 2, and I plug in z to that one, I have x plus y plus, and this time in the parentheses I have negative 2y plus 3 for my z, and that equals a negative 1. So that's x plus y minus 2y plus 3 equals 1. You can combine like terms. Y and negative 2y is minus y. And if I subtract 3 from both sides, that's going to equal negative 2. So now I have 2 equations here. And actually, look at that. Oh, this is a negative 1. It helps if you copy the problem down right to begin with. So this is a negative 4. So now what I'm going to do is I'm going to combine these 2 equations. So I'm going to add 1 and 2 together. So I have 2x plus 5y equals negative 1. And I have x minus y equals negative 4. And I want to eliminate one of those variables. And it doesn't matter if you eliminate the x or the y, you just have to pick one. And what I'm going to do is I'm going to pick, let's just pick the let's change the y into, multiply both sides by 5, or multiply the bottom by 5 so that this one eliminates. So that means I've got 2x plus 5y equals minus 1. That one's not changing. And then I multiply the bottom times 5. That gives me 5x minus 5y. I did that so the y's would eliminate. Equals minus 20. And this is a minus 1 here. So 2x and 5x, 7x. This eliminates. Equals negative 21. So my x is negative 3. So I've solved for my first variable. I still have to solve for y and z. And this part really isn't too bad. If you look, number 2, this is in terms of x and y. So if I plug in x here, I'll be able to solve for y. So I have negative 3 minus y equals negative 4. I'm going to add 3 to both sides, so negative y equals negative 4. Excuse me, negative 1, because I'm going to add 3 to both sides. If I divide both sides by negative, I have y equals 1. So that's my y value. All I have left is my z value. And I can actually plug it into this one up here. If I know y, I can plug that here and find z. So I have negative 2 times my y minus z equals negative 3. And my y, I found out, is a positive 1. So this gives me negative 2 minus z equals negative 3. I'm going to add 2 to both sides. So negative z equals, if I add negative 2, if I add 2, that gives me negative 1. Divide both sides by negative 1, and z equals 1. So my solution is x is negative 3, y is 1, and z is 1. Just put them in alphabetical order, and that'll take care of it. So that's the first problem. And again, you just sort of have to manipulate down, and the problem with this is there's not only one way to do it. What you want to do is get things down to 2 variables, solve those, and then plug back in. So on this one, what do we notice? It says don't write anything down. And what I notice is the letters are not in the same order. So the first thing I always do is make sure the letters are in the same order. So I have 2 on the first letter, or the first equation, I have 2x minus 5y minus z equals -8. And then I have negative x plus 2y plus 3z equals 13. And notice I'm just putting everything in alphabetical order. Then I have x plus 3y minus z equals 5. So at least I get them so I line them up. And I'll tell you that the one that looks the easiest to deal with right now are these 2. I've got 1, 2, and 3. If I add 2 and 3, that's going to eliminate the x. So if I add these 2 together, the x's eliminate. 2y plus 3y is 5y. 3z minus z is a plus 2z. And 13 and 5 is 18. Okay, so that gives me that one. And if I add, I need to get something else down to y and z. So if I look at 1 and 2, if I multiply the bottom one times a positive 2, that will get rid of my x's, and I'll be left with y and z. And what you're looking for is you want to combine 2 more sentences so that the 2 variables are y and z. And that's what I'm doing with 1. So if I multiply the bottom by 2, the top one's going to be 2x minus 5y minus z equals -8. If I multiply the bottom by 2, I have negative 2x plus 4y plus 6z equals 26. You can multiply the whole thing by that. This will allow me to eliminate the x's, which is what I'm trying to do. Negative 5 and positive 4 is negative y. 6 and negative 1 is a positive 5z. And 26 minus 8 is 18. Okay, so then I'm going to combine these 2. So I have 5y plus 2z equals 18, and negative y plus 5z equals 18. I'm going to multiply the bottom one by 5 so that I can eliminate the y's. You're always looking to eliminate a variable. If I do that, the top one stays the same. The bottom one becomes negative 5y plus 25z equals 5 times 18, which is 90. These eliminate. So I have 25 and 2 is 27z. 90 and 18 is 108. So I'm dividing both sides by 27. And 108 divided by 27 is 4. So now I know that z is 4. So I have at least one of the variables. I'm going to plug that in to one of the other equations. And it doesn't matter which equation I plug it into. I'm going to plug it into this one just because it's convenient. I have negative y equals 5 times 4 equals 18. Oops, not equals, plus. It says y plus 20. If I subtract 20 from both sides, I get negative y equals negative 2. The Bible says by negative 1, and y equals positive 2. So the last thing I need is the x. I can plug y and z into any equation to get my x. I'm going to just plug it into the last one. So my last equation is negative z plus 3y plus x equals 5. I'm trying to solve for x. So I know z is 4, so the opposite of 4, plus 3 times my y, which is 2, plus x equals 5, plus negative 4 plus 6 plus x equals 5. Negative 4 and 6 is 2. If I subtract that from both sides, I get x equals 3. So my solution is my x is 3, my y is 2, my z is 4, and that's your answer for your solution. Okay, we're going to do one more. And what's fun about this is I've done these multiple times, and every time I do it kind of a different way. I solve for different letters. So there's not just one right way to do this. It's just a matter of narrowing down your letters. As far as the strategy goes, first thing you want to do is narrow 2 of the equations down to 2 of the same letters so that you can solve those. Then once you solve those, then you just start plugging back in. So I've got 1, 2, and 3 here. And and these are in alphabetical order. I want to eliminate something. So I'm going to add 1 and 2 because the y and the negative y are opposites, so that'll get me down to my x's and z's. So if I just add these, x and 4x is 5x. The y's cancel. 2z and 3, negative 2 and positive 3 is a positive 1z. And 3 and negative 1 is a positive 2. So that's what I get when I add 1 and 2. Now if I add 1 and 3, I could do that and get it down to x and z. If I could eliminate the y's there, I would have to multiply the top by a negative 2 in order to eliminate my y. So if I make this negative 2x minus 2y minus 4 or plus 4z equals a positive 2, and then use this as it is, which is 3x plus 2y minus z equals 4. The y's cancel, so now I have x plus 3z equals 6. And what's cool about that, now I've got 2 sentences that have the same 2 variables in them, and I can put those variables together, or I can put those sentences together to eliminate a variable. So what I have to do is decide what I'm going to multiply by. And I can multiply the bottom by a negative 5 or the top by a negative 3. It really doesn't matter which one I do. And I'm going to multiply the top by a negative 3. So that gives me a negative 15x minus 3z equals negative 6. And if I combine these cancel. Negative 15 and x is negative 14x. Negative 6 and 4. Negative 6 and 2 is a negative 4. Something isn't right. Let's see what we got. And I know that because I happen to know that the answer is not a fraction. So this is a really good example of how you go back and you figure out where did I go wrong. So we have 5x plus equals 2. And I have x plus 3z equals, oh, here's the problem. I put 2 and it's really 6. So if you don't copy the problem right, you're going to have a wrong answer. So it's really important. This is a really good example of how it's important to pay attention to what makes sense and what doesn't. So then if I multiply that times 5, this is a minus 30, right? Because negative 5 times this is negative 5x. Ooh. Let's back up. Okay, so I'm multiplying the top one. Negative 5 times 5 is negative 15. Negative 3 times that is minus 3z. Negative 3 times 2 is minus 6. This is starting to look better. Now if I add, these cancel. 6 and negative 6 are 0. X and negative 15 is negative 14x. Divide both sides by negative 14. And my x is 0. That makes more sense. Now I can use that to plug it in anywhere to try to find one of my other variables. So what I'm going to do is I'm going to take this one where I've already, all it is x and z. This will let me find z. So if I plug in 0 for x plus 3z equals 6, that means that 3z equals 6. Divide both sides by 3 and z equals 2. So now I have my x and my z. I just need to find y. And what I'm going to do is I'm going to take this first equation. And it doesn't matter what equation you take. Just make a choice. I have 0, that's my x, plus my y, that's what I don't know, minus 2 times my z, which is 2, equals negative 1. So this is y minus 4 equals negative 1. If I add 4 to both sides, y equals positive 3. So your solution is going to be my x, 0, comma my y, 3, comma my z, 2. And that's your answer. More fun than humans should be allowed to have.